Hello everyone, welcome back. So in our previous video, we have discussed about our model evaluation pipeline. So in this particular video, we will be discussing about the model pusher part. Okay, so what we have to do, we'll just create one new file inside our SRC inside components. So will be a new Python file that we need to create, and that file name will be model pusher.py. So this will be the file name. Okay, so cancel it as of now. So now in model pusher, simply what we need to do, okay, we have to take the model from our model evaluation folder, or maybe from the model trainer artifacts folder, okay, and we have to push it to the Google Cloud Storage. Okay, if our currently trained model will perform better than the model that is present on the Google Cloud Storage, then we'll push that model to the Google Cloud Storage. That's the thing we have to do. Okay, and we have already completed till this model evaluation part. Now simple code we will be writing to push the model to the Google Cloud Storage. Okay, so we will be importing few of the libraries, so I'll just write it. Import sys. We will be requiring logs as well that we need to maintain. Import from logger, from src.logger import logging. Okay, and then from exception also we need to write exception, import custom exception. The cloud syncer also required because we need to push it. So src.configuration cloud syncer, then gcloud sync storage. Also we will be requiring the model pusher config. So what I'll do, before starting model pusher component, what I'll do, I'll just create the config, okay, that what all configs required for our model pusher pipeline. Okay, so I'll write it and I'll explain you what all things is required. So very basic things are required, not much. Okay, so we need to read the YAML files. Few of the parameters will be written in this YAML. Second thing, we need a model name, okay, which model we want to push it, and another thing that is required, that is bucket. Okay, where exactly we want to push it, which bucket. Okay, that's the thing. And what will present inside the config.yaml, that also I'll write it and I'll explain you that as well. So only one thing is required, that is bucket name, nothing else. To push the model we need bucket name as only, nothing else we will be requiring. Okay, fine. So I'll just import that as well. src.entity dot config entity import model evaluation config. Okay, now what I'll do, I'll just create a function with the name of model evaluation, model pusher. Sorry, even I need to sorry, by mistake I have written model pusher config will be there. Okay, now we have to create the model pusher class. We'll define the image part. What all parameters it will take? It will take first parameter as a model pusher config. So I'll just write it here, model pusher config, and then we call model pusher. Another thing will be requiring, once our, let's suppose our model, we need to push our model, right? So from where we'll take that model? We'll take that model from our model trainer artifacts. Okay, so we have to import that as well, src.entity.artifact entities and model trainer artifacts. Okay, so I'll just write it, model trainer artifact. So this thing is important. Now I'll write docstring as well. That is also important. We need to keep this thing as well. Model pusher config and model trainer artifact we will be requiring. I'll just define them. Model pusher config for this one, model trainer artifact, and Google Cloud Syncer, just to use when we have to push our model to the Google Cloud Storage. Now we will be writing a simple one function will be there inside that. Whatever things we will be requiring, I'll write it. So initiate model pusher we have writing, and it will return the model pusher artifact. So even the model pusher artifacts that we need to define inside our artifact entity. So I'll do one thing, I'll define it that as well. So only one thing is required, and that is artifacts that we are generating is the bucket name, nothing else we are generating, only the bucket name we will be saving as an artifact from this model pusher artifact. Okay, and we need to import that as well. So model pusher artifact. So what we are doing inside this model initiate model pusher, so first thing is that we are just trying to fetch, okay, sorry, we are just trying to push sync our file to Google Cloud. So we are uploading the model to the Google Cloud storage, and for that the parameters that will be requiring, that a bucket name and where exactly the file is stored as of now. So the file, the model that we have trained right now, so that is stored inside this model trainer artifacts dot trained model path. Okay, so it will upload that model.pt to Google Cloud storage, and it will generate the artifact, only the bucket name, okay, in which bucket exactly it is pushing our model. So we are keeping it in the artifact folder. Okay, now we need to run this model pusher pipeline. So we, as it is a part of training as well, so we need to define it here as well. So first of all, we need to import some of the things like src dot components dot model pusher. We will be importing model pusher. Okay, last thing also we need to mention it here, model pusher config will be there, and model pusher artifact will be also there. Okay, now we need to define it here as well. So I'll just write it here, model pusher config. So it will be self dot model underscore pusher dot underscore config. Okay, and we need to write start model pusher function as well to start model pusher. So I'll just write it and then explain you what all things required. So this is a start model pusher function. So it requires only one parameter, model trainer artifact. Okay, because we are going to push model from the model trainer only. Okay, so we are calling this model pusher class, this class, and this requires two parameters. Then first is the config, model pusher config, second is the model trainer artifact. Okay, after that what we are doing, we are just initiating the model pusher, this one we are initiating. So inside that what it is taking, it is taking the bucket name and train model path, and it is pushing to the Google Cloud storage, and it is returning the artifact, and the artifact will be the bucket name, where exactly. Okay, now the time to run this model pusher component. To run this, what we have to check first, like whether the artifacts generated from this model evaluation artifact is true or not. As in you can see in the model evaluation artifact, we are storing is model accepted is true, like we are storing a boolean value. So if our currently trained model is better than the model that is present on the Google Cloud storage, then only we will run this model pusher component. Okay, so we'll write the one statement for that, if a statement. So if not model evaluation artifact is accepted, okay, if not it is accepted, then raise a exception like trained model is not better than best model. Else, if trained model is not better than best model, then we won't push anything. Else what will happen, model pusher artifact will run. Okay, and once the model pusher artifact will run, it will generate a artifact and the artifact is bucket name. Okay, so that's all with this model pusher pipeline. So what we need to do now, we need to run it and check whether this particular component is running perfectly or not. So what we need to do, we need to just write python then main.py, and I'll hit enter, and we'll have to wait it. I'll make it big so that it will be visible. So it is loading the data, sorry, loading the data from Google Cloud Storage. You can see that. Now the training will start. If we can see that as well, if we can reload it, so you can see that the artifact is generated, data transformation is done, ingestion artifact is also done. Okay, now training got started. Just wait for that. Okay, now you can see that it is not able to fetch model from the bucket because the model is not present right now, because the first time we are training and pushing our model. So the file is, now you can see that the model is pushed to Google Cloud Storage. If you want, I can show you that. Like, this is the bucket name that we have created. If I'll click here, and I'll have to refresh it as well. Okay, I think by mistake I have given some different name. Let me check what's the issue. Okay, I have given the wrong bucket name. Okay, the bucket name will be this one. Let me run once again the project. Okay, let me run once again. The model was pushed, but it got pushed to the different bucket. Okay, so I'm just training once again and it will be pushed there. Started training. Now model is getting pushed. It's got pushed. Now what we'll do, I'll just check it once again whether it got pushed on. We are in the sign underscore hyphen recog bucket. I'll refresh it. Okay, now you can see the model got pushed here and it just now got pushed. Okay, you can see the date. Okay, so it just now got pushed. Okay, so we are done with this model pusher pipeline. So that's all for this particular video. Hello everyone, welcome back. So in our previous video we have seen the training pipeline by using fast API. So in this particular video we will be discussing about the prediction pipeline. So let me open PyCharm and then we'll start coding. Okay, so in our previous video we already discussed about the little bit introduction about the fast API, and we have done the training by using fast API as well. So in this particular video we will be writing our prediction pipeline, as well as we'll do the prediction by using fast API as well. Okay, so what we need to do first, we will be just open this pipeline, and we have to create one Python file there, and the Python file name will be prediction.py. Let me write it here. So what exactly like in this prediction.py that we need to do is very simple. What we have to do, first of all, whenever we'll call the prediction pipeline, so what it will take image from the user, and then what it will do, it will download the model from the Google Cloud Storage, and it will pass that particular image to that particular model for prediction. And once it got predicted, it will just tell us like whether that particular image is original or forged one. Okay, so that's only the thing that we need to write it. Okay, so we will be importing few of the libraries related to that, so I'll just write it and I'll explain it. So these are very common libraries, like says they are a PIL image, just to read the image. Okay, And also we will be importing everything from the constant. Okay, logging is important, custom logger that we have. And from torch vision we are using this transform as well. Okay, we need to transform our image as well. So, and also we will be requiring the custom exception, and also we required something from our config file as well. So config.yaml file, so we need to write some of the parameters from there as well, so we will be defining later on. Okay, and also one thing that I have mentioned here, this one, from src dot configurations dot gcloud syncer import gcloud. So that's one. Also we, so what you need to do, instead of configurations it is, so because of that it is giving us error, nothing was there. Now what we need to do, we'll simply create a one class. Okay, and before that I'll just write whatever things will be required for this particular prediction pipeline. So in this YAML file, what we need to write it, we need to write the bucket name. Let me write it and I'll tell you. So for prediction pipeline config, we will be using a image. Okay, and once the image will be provided by the user, and that image will be saved to our local. Okay, and the name of that particular image will be input.jpg. Okay, and after that it will take the model from this bucket. So let me modify the bucket name. Okay, and the model, and from the bucket the model will be model.pt. Okay, and threshold we are keeping it 0.3. Okay, now go to the prediction pipeline, and now what we need to do, we need to create a class. Okay, so I'll simply write it, prediction pipeline, and inside that we need to call these things. So I'll just write it and I'll explain you. Okay, we will be requiring the Google Cloud Syncer. Okay, just to get the model from the Google Cloud storage, and also we need to read the config file. For that, read YAML file function is important. Okay, and also from the data config, we will be requiring the image size. Okay, so image that we are going to, like, if from here you can see this one, data transformation config, we will be taking the image size. So whatever image we are providing, so that image should be converted in this particular format or size, you can say. Okay, now we'll just create a function first. Okay, so the first function that we are going to create here is that the image loader. So once the user will provide the image, so we need to load that particular image to our local system, and to loading that image, we have written this particular function. So once the image will be provided, that image will be in the byte format. Okay, and we need to save that byte image to local. Okay, so what we are doing, we are just what this is the image. Okay, we are just taking a input image name. Okay, and whatever image it has taken in the byte format, we are saving it. Okay, so once this function will run, so what it will do, it will create in this particular, inside the signature recognition, there will be a file present with the name of input image.jpg. Okay, that's the use of this particular function, just to load the image from fast API and convert it, save it into the local. And after that, what we need to do, we need to get the model from our Google Cloud storage as well. Okay, so this function is for that only. So what we are doing in this particular function, simple, get model from gcloud. Okay, so we are making a directory first. Inside artifact, we will be making a directory with the name of predict model. Okay, inside that the model.pt file will be kept there for prediction. Okay, so what we are doing, we are just passing there the bucket name. Bucket name is also already mentioned there in the config.yaml file. That's the bucket name, and this will be the file name that it is going to fetch it. Okay, and where it will be stored, and it will be stored in this predict model path, and that model path is nothing but inside artifact there will be a folder with the name of predict model. Okay, and it will return the best model path. Wherever the model will be stored, it will return the path of that. Okay, and after that we will be writing the prediction part. Okay, so what we are doing in the prediction part, when we'll call the model.predict, so what will happen inside that, so that also we need to define it, right? So for that I'm writing here. Fine, so what we are doing here, we have defined the predict function, and it takes two parameter. First is the image path, you can say, and the best model path as well. So we are loading that particular model, okay, and based on the device, whatever device you are having, CUDA or CPU, and then model.eval we are calculating, and then what we are doing, we are performing some kind of a transformation on that particular image. Okay, we are converting that image into some kind of a size, and the size is 224 cross 224. Then we are converting that grayscale, okay, and then tensor, okay, and so we are performing this preprocess inside that image we are passing. That's one. Now we are converting that image with respect to our device like CPU or CUDA. Then that particular image will be passed to our model that we have taken here. So in this particular model, image is getting passed, and then we are calculating, going to get the probability. Okay, but like what will be the probability, like it will be in the form it will be in between 0 and 1. Okay, so like if it is more than 0.5, then it will be related to the positive, or maybe you can call that the original one. Okay, so the label name we haven't defined, so I think label name I need to define inside our constant. So let me define it that as well. So because of that, it is giving is the red mark. Okay, so what I'll do, these are our labels, forged and original one. Okay, original. So now if you can see here, this one, the error is gone. So simple thing is there. Okay, we are predicting it. Okay, and after that we are mapping the labels, and then we are simply returning the label name. Okay, exactly which class it belongs to. Okay, that's in for this prediction function. And then what we will be writing here, there will be a run pipeline, so that will help us to run all the functions that we have created till now. So inside this run pipeline, what we are doing, we are first calling this image loader, and then once the images get loaded, then we are calling the this get model from gcloud. So then model will be loaded from Google Cloud Storage. Once the model is loaded, then that model path is provided to the prediction function, this particular function, and the image as well. And once this image got, like, the label is once it returns the label, so even we are returning the label. Okay, that's in for this prediction.py file. Now what we need to do, we need to call this particular prediction.py file in our app.py. okay, just to integrate this thing with our fast API. What we need to do, we will be creating a function. Okay, so let me write it and I'll explain you what we have to do here. So in this prediction, so even though we need to import it, the prediction pipeline, so the prediction pipeline is inside our src.pipeline.prediction. so now you can see there will be one space. So fine, so we are calling a synchronous function prediction. Okay, and inside that we are calling this prediction pipeline, and that is this one only. Can say this prediction pipeline class we are, and inside this class we will be having a function called run.py, run underscore pipeline. This function is getting called, and inside this particular function, image file is passing. Okay, so the image that is taken by the user from the UI part. Okay, so what we need to do now, we'll simply save this one, and now what we need to do, we'll simply run this file app.py. So now it's got running. So what we need to do, I'll simply go here and then go open it. Now we can see earlier it was only showing us the training part. Now even the prediction is showing. So I'll simply click on that and click on try out. We need to select the image. So what I'll do, I'll just simply select one image, click on open, then execute it. So now if you can see in this part, so you can see the model is getting downloaded from the Google Cloud Storage, and it will be stored in this one. As I said, it will be stored in our artifact folder, and inside artifact there will be a folder that will be getting generated with the name of predict model. Okay, so you can see the model is getting downloaded, and after that prediction will happen. So you can see this one, forged one. Okay, so but the image that we have taken, that is from the original one, you can see there, but it is giving us the prediction as a forged. So because the model we have trained, that is not trained on more number of epochs, it's just a one epoch that we have trained it. Okay, so that's all for this prediction pipeline. Okay, We'll talk about the rest of the things like Docker image or Airflow integration in our next video. Hello everyone, welcome back. So in our previous video, we have discussed about the model pusher pipeline. So in from that pipeline, we have completed our complete training pipeline. So what we will discussing in this particular video, we will be creating a web app by using fast api, and we will do the training through that one. Okay, so what we have to do, we will be creating one python file. The name of that file will be app.py, and whatever things related to the UI part, we will be writing inside that fast api part, we will be writing inside this one. Okay, so now if I'll refresh it, so you will be able to see app.py file got generated. Okay, so now we need to write few things here before running this app.py. So we will be importing some of the libraries, okay, related to the fast api. So I'll just write it and then explain you these things. We will be writing like the fast api we need to import, as we have already installed this fast api in our requirement.txt file. You can see that fast api and uvcorn is mentioned there, right? So that's what we are importing here, fast api, uvcorn, and inside that multiple libraries that we are going to use, like response or json response. Even though we need this app host and app port, like which exactly url host means, like exactly at which url our app will be running and at which port number, so that we need to mention inside our constant. So first thing that we will doing, we will be mentioning this thing in the constant file. So let me open our constant. Okay, so if I'll click on constant and init.py, okay, so what I'll do is it will be a kind of, so let me mention it here downward, or maybe I'll mention it in this part, because even this one is a common constant. Okay, so app host and app port. So now if you will see here, now the error is gone, now there is no any red mark here. Okay, and just forget about this prediction pipeline, because as of now we haven't discussed about the prediction part. So maybe later in our later videos we will be discussing about the prediction pipeline. So in this particular video, what we have to do, we have to do the training part by using fast api. Okay, so the things that we need to write it inside that. So first of all, the what we need to write, we have to mention there, just like flask app, even we need to mention here as well, fast app is equal to fast api. Okay, and also we need to mention the origin, so origins will be like that. So that abstract we have to give. So that's the structure of fast api. Okay, app dot add middleware, and inside that we need to mention other things like whatever things we have imported. Okay, that thing we need to mention there, like course middleware is there. Allow origin, inside that let me write it here, allow underscore origins, and that will be origin that we have defined right now. And allow credentials is also there, so credentials, and that will be true. Yeah, so credentials are allowed. Okay, allow method, so we will be using post and get method, right? So we need to mention that as well, allow methods, and that will be also, we need to mention that abstract there. And after that, allow headers as well. Yeah, same thing we need to mention. Okay, that's fine with that. Now what we need to do, we have to create an app. Okay, we'll just write here app.get. Okay, and what we need to do, we need to train it, right? So we'll just give it a name, train, and inside that we'll create a asynchronous function, async def training, with the name of training. I'll just write it here. Okay, and inside that what we need to do, first also we will be writing the exception. Okay, so here we are not using our custom exception, normal exception that we are going to use it. So what we will be doing, training pipeline will be there, and we will be calling the train pipeline that we have imported here, training pipeline. So we need to call this particular function just to train our model, right? And to initiate the training pipeline dot run pipeline function we have already created there. So, and once the training will be finished, so then we will expecting one response. Okay, so return response. So I think I need to write it this way, and in response what we will be writing, training successful. That will be better. Training successful, like that. All right. Okay, and also we need to mention the accept condition. So accept exception as e, and what will be in the return when the exception will occur. The in response what we'll get, we'll simply get message error occurred, and due to what, for that I'll just mention e. So whatever will be the error, it will be go inside that. Okay. Yeah, so this is all about the training pipeline. Okay, so what we will be doing now, we'll simply run this app.py and we'll check whether we are able to train our model or not. Okay, so what I'll do, I'll just simply save this one first, save all, and now I need to do what, I need to run this app.py. Yes, app.py while running, so it will take few minutes, a few seconds only, not few minutes. Okay, so it is not returning anything. Okay, there is one thing is missing here, so we haven't just written the main part, so that's the thing it's not able to do. So main is there, we need to call this app. Okay, and then we have to mention the host name, like the URL and the port number. Okay, so that's what we have already defined over this in this one. So host will be this one and this will be the port. Okay, exactly. So I'll run it once again. So now you got the URL, so let me copy this one. Copy option is there. Yeah, copy is there. Now I'll open the browser and then I'll paste it here and hit enter. So what we need to do is a fast AI. So fast API is there, so sometimes it won't work with this 000. So instead of that we can try with the local host or maybe this one. Okay, now you can see it's working and we have created a function here. So synchron function was there like train, so we have to just click on that and then I'll click on this try out. Once I'll execute it, so you will be able to see the training will start here. Okay, so what I'll do, I'll just click on execute first. I've executed it. So now if you can see here in this so now our training got started. Let me this one. Okay, so now you can see the dataset is loading from the Google Cloud storage, and soon it will start the training as well. So it will take a few minutes, I think. Okay, so we'll wait for that, and then now even training is started. I have just given the one epoch in the config file. You can see that, just to save some time. Okay, so one epoch is there. You can mention whatever you want. Here you can see it's loading and here it is executing. Everything get executed here. It will take some time. Now training got started. After that evaluation will be done. So now if I'll click here, you can see there is an exception raised. Okay, model training is done. The exception what it is raised, train model is not better than the best model. So because of that, it raised the exception. We have already done with the model evaluation part, like, but in the model pusher part, what happened, the model that we have trained just right now, okay, it is not better than the model that is already present on the Google Cloud Storage. Okay, so because of that, the model pusher didn't work. Okay, so if you will train your model for more number of epochs, so it will be able to push your model, and then your training will get successfully. Then you will get a message here, training successfully. Okay, so that's all for this particular video. Thank you. Bye bye. Hello everyone, welcome back. So in our previous video, we have already talked about the training and the prediction pipeline. Now, what we have to do, we have to deploy our project on any of the cloud platform. But before deploying the project, first what we need to do, we need to create a Docker image of this particular project. Okay, so just to create the Docker image of this particular project, we will be requiring a Docker file. So what we will be doing, we will be creating a Docker file, and inside that we will be writing some of the commands to create a Docker image of this signature recognition project. So let's go ahead and start doing that. Okay, so what I'll do, I'll just create a Docker file first. So touch Docker file. Okay, this is the one way to create it, and you can do it by using this one UI part as well. Like, you have to just right click on that, click on new, and just click on the file and write the name Docker file. Okay, and make sure Docker file doesn't have any kind of extension. Okay, the file name will be only Docker file, nothing else we have to mention there. Okay, so as we have already mentioned here, touch Docker file, so a Docker file will get created here. So if I'll just reload it, so you can see the Docker file got created here. Now we need to think like what all things we need to write inside this one to create a Docker image. So let me open this one first. Okay, so as we all know, in this particular project we are working on the Google Cloud. Okay, like we are getting the data from Google Cloud Storage, GCP, right? And also, even though we are pushing our model to the Google Cloud Storage, right? So instead of so what we are thinking, okay, just create a image, create a Docker image of Google Cloud Storage, so that we don't have to think more about the authentications. Okay, so what I'll do, I'll create a Docker image of Google Cloud. So from Google slash Cloud SDK latest. So the image that will be get created, and that image will be of Google Cloud, and inside that image what we are going to do, we are just creating our own work directory. Okay, and that work directory will be sign. So there will be a folder will get created, and inside that folder all the files will be copied. Okay, so we need to write that as well, copy dot space slash sign. So everything, whatever things will be present in our current working directory, like this one, whatever things like artifact, config, log, no, notebook, src, whatever things are there, right? So everything will be copied in this particular folder. Okay, so in our work directory. So once we have created a work directory and we have copied all of the content inside our work directory, now what we need to do, whenever we are, as you know, like this Google Cloud SDK image is a kind of a Ubuntu image. Okay, so we need to do some of the updates there, right? So apt update -y. So just -y we are mentioning, like, so that it won't ask us to approve, like yes, no, or something like that. So because of that, we are just writing -y. So we are already giving him a permission to get executed. After that, also we need to update some of the things. So I'll just write it everything here, and then explain you one by one what all things will be required. Okay, apt update, and then also we need to install pip upgrade. We need to upgrade the pip as well. So pip upgrade and give a and sign, then again a slash. That's it. There won't be a space. We don't need to give that space. And after that, one more will be there, apt-get install ffmpeg Don't worry, I'll explain it what exactly it is. These are the important libraries, okay, because it's the Ubuntu image, so we need to update these things, okay, then only we will be able to create the container, a good container. Now, so these things will be installed, okay, and after that, what we are using here, Google Cloud, right? So we need to authenticate our credentials as well. So for that also we need to install some of the things, okay. So we will be writing apt-get and then install, let me write it, apt-transport, this thing we need to do that, apt transport https ca certificates gnu y, and one more thing that we need to install is that is Python, okay, because it's the Python based project we are doing, okay. And after that, what we have to do, like if you can see in the requirement.txt file, I didn't mention about the PyTorch package, as I have already told you, like it depends upon the system, right? Like in Docker image, definitely we don't have the GPU, so we'll go for the CPU image, right? So CPU version of the PyTorch. So I'll just write it there. So what it will do, it will install the PyTorch and that too CPU version of it, okay? And the rest of the things will be installed from the requirement.txt file. And after that, pip install -e dot just to create this src as a package, okay? So this src will work as a library there. Just to install that, we are writing here pip install -e dot. Once everything is installed, now what we need to do, which file will get executed first, right? So let's suppose we have created that Docker image, right? So now we need to tell Docker as well, right? So which file you need to execute when I'll run that Docker image, right? So we need to run this app.py file, okay, because this is the main file. Everything, whatever things like related to training and prediction, everything is written inside this app.py file. So we need to tell Docker image, right? So this particular file you need to run, and this particular file is a Python file, okay. So now we have created our Docker file. Now what I'll do, I'll just simply save it, and we'll test this Docker image, like whether this particular Docker image is working or not. So just to run this particular Docker image, you should be having Docker installed in your system. I'm not going to show you the installation part, but if you are using Windows, okay, so let's suppose if you are using Windows, so let me show you how you can install it. I'll just Docker install Windows. So this one you need to install it on your system, okay. Steps are already mentioned there for Windows and for Linux, whatever distributions you are having, okay, according to that you can install it. All the steps are mentioned there, okay. But so I have already installed Docker image. So if you can see, so if I'll show you, so this is the Docker, this is my Docker, okay, it's still running. You can see the engine is running. So what I need to do now, I need to build that particular image, okay. So just to build this particular image, we need to write a command docker build -t, and we need to give a image name. So I'll just give, because it's a signature recognition, so I'll give it sign and then give a space and then dot, and then I'll hit enter. So it will start building the image, and it will take some time depending upon the image size. So we have taken the Google Cloud SDK image, so it will be something around 7 or 8 GB, okay, and it completely depends upon your internet speed, how much time it will take. So what I'll do, I'll just pause the video for a few minutes, okay. Once the Docker image will get generated, and then we'll start again. Okay, yeah, so it's done now. So if you can see here, it took almost 446 seconds to complete the installation process, or you can say the Docker image creation process. So almost 7 minutes or something, like 30 seconds, something around that it took. Okay, so now I'll just go to this Docker. Okay, now you can see a Docker image got generated with the name of sign. Okay, you can see that. Now what we need to do, we need to run this Docker image to test whether the Docker image that we have created, is it working or not. So let me clear this terminal first, and then I'll write the docker run command. So it's docker run, then a space -d -t is for port, so I'll just map the port, because as you can see in the app.py file, this is the app port. Okay, and this app port is mentioned in this constant file, right? So it's 8080, so we are mapping the 8080 port with the 8080 itself. Okay, and now what we need to run, we need to run the image, so we have to give the image name as well. So the image name that we have created, that is with the name of sign. So I'll just hit enter, so you can see that now it's got running. So if you can see, now this is the image. If I'll go click on the container, you will see there will be a container running. So you can see here this container is running, and this just got run 10 seconds ago, right? 14 seconds ago, right? So what I need to do now, I'll just simply go to the URL and just check it whether this particular thing is running or not. So it is running on port number 8080, and as it is a fast API, so we need to write /docs. So if I'll hit enter, you can see this API we have already opened our this fast API. Now what we'll do, we'll just simply test it whether the image is working or not. So we'll go with the prediction. So I'll just click on the prediction, try it out, select some image. Okay, so I'll just go there and then select some image from our project. Okay, maybe from where exactly some the image will be there. Yeah, I'll this one. Okay, I'll just take a image, okay, and simply execute it. So you can see okay, so there is an error here. Okay, let me try to fix it. Okay, let me try to fix it. Okay, so you can see we are getting the error, the predict model and /model.pt. So the thing is that we are not able to fetch the model from this model.pt. So what we are missing here, so let me tell you that. Okay, so we'll go to the image first. Okay, I'll click here, not to the image, click on the container. If I'll click here, I'll open a terminal. Okay, what we need to do now, okay, as of now, what we have to do, we have to fetch the model from the Google Cloud storage. Okay, but we haven't provided the credentials where exactly it has to fetch the image, like model. Okay, so in the readme file I have already mentioned there. So what you need to do, okay, whenever we will run the Docker image, so first thing that we need to do is this one. We have done it, right? This one, to just to open our Docker image in the interactive mode if you are using a Ubuntu. Then because if you're not using if you are using a Windows one, then it's already opening in the interactive mode, so then you don't need to use this one. After that, we need to authenticate our Google Cloud, okay, storage. So I'll just copy this one and authenticate it. Okay, if I'll click in here, so now I'll got this URL. I'll have to just open there. So once I'll open it, okay, it will ask for the authentication. So I'll just need to enter the password. Just give me a second. Yeah, so I have entered the password, and after that it is asking me to like allow all of these services. So I'll just simply click on allow. So you can see that we are getting this one. So I have to just copy this one and paste it here and hit enter. Okay, that's the thing. And another thing was there that also we need to mention it. This one, Google Cloud Application Authentication. So that also I need to copy it, just paste it here, and I'll get the URL. I'll just click on that, allow, copy it, paste it here and hit enter. Okay, now it's done. Now what I need to do now, I will again execute this one. So I'll just simply refresh it, click on try it out, select one image again, click on open, then execute. Now wait, it will take a few seconds to load the model from Google Cloud storage, and then it will give us the prediction. Just wait for a few seconds. Okay, so now you can see that, okay, we are getting the prediction. Yeah, I know that it's not correct, but because the model that we have trained is just for a one epoch, we need to train the model more for more longer duration. Okay, so we have tested like the Docker image that we have created, it is working perfectly fine. Okay, so that's all for this particular video. From next video we will be discussing about the deployment part. We are deploying the same Docker image to the Google Cloud Storage. Thank you. Bye bye.